Hi, I'm Catherine Gilbert. I'm a senior geospatial consultant in Land Use Victoria within the Department of Environment, Land, Water and Planning. Today I'll be presenting on harnessing geospatial data and emerging technologies to make public land work harder for our communities. Land Use Victoria has been fully engaged within the digital innovation space because we know that digital innovation can unlock some of the most complex challenges our communities are facing. This slide shows some of the landmark spatial innovation projects currently underway within Land Use Victoria. So Fisherman's Bend Digital Twin is a digital twin that consists of over 1,000 data sets and was Victoria's first digital twin. A digital twin is a digital representation of the real world object, system or place. The Fishbend Twin was a critical pilot to building essential capability and skills. And this twin really demonstrated how innovative technology can transform planning, modelling and processes. Digital Twin Victoria is building on the strong foundation of spatial innovation and lessons learned from the Fisherman's Bend Twin. Digital Twin Victoria is centred around using data to increase productivity and innovation by helping create a more livable, sustainable and resilient Victoria through data-driven digital innovation intelligence. Digital cadastre modernisation. This project is a $45 million project to upgrade the authoritative map of the state's property boundaries to become more accurate, modern and easily accessible. And earlier this morning you might have seen the presentation on BudgeBIM. So this involved using high resolution imagery and LiDAR to uncover hidden culturally significant sites that date back more than 6,600 years. As I mentioned earlier, Fisherman's Bend was Victoria's first digital twin. Fisherman's Bend itself is a priority precinct for Victoria and it's Australia's largest urban renewal project. So because of this, we did a proof of concept project to see how we could use machine learning to map trees in this precinct. By applying the innovative technology of machine learning feature extraction, we found great cost and resource efficiencies were gained. The proof of concept identified just under 10,000 trees in approximately 30 minutes. It is estimated that a human analyst would take approximately 14 hours to heads-up digitise the same amount of tree points. Following the success of this project, we are currently using machine learning to create scalable vegetation products for VicMap. So this is the project I'm involved in. This is where we're using machine learning to extract vegetation for 2 statewide data sets to go into the VicMap vegetation portfolio. We're using machine learning and leveraging coordinated imagery program captured imagery to create 2 statewide products. So examples are shown on the slide. We're creating a vegetation extent raster. So this is where the algorithm actually identifies pixels as vegetation within the imagery. And from that raster, we're creating a tree density vector. So it's a subset of the vegetation extent raster, and the density will be broken into 3 classes, so dense, moderate and sparse. These data sets were identified as being significant for stakeholders because the previous vegetation density data was created over 20 years ago and is now not fit for purpose. Having an understanding of where the vegetation is and the density of the vegetation that we are looking at is important for being able to understand and manage land. Public land use cases for these data sets include identifying available land for site selection, green space reporting, and heat mapping, amenity and livability ratings. We're hoping to finish this project in the next 2 months. We plan to make both data sets available for download. Land Use Victoria has also developed a range of other spatial platforms, including GovMap and eComply. So GovMap is a web mapping platform through which government employees can search and visualise core information on government-owned land. With the Victorian government owning over 8 million hectares, or approximately 40% of the state, accessing this information in a centralised, authoritative platform enables more informed decision-making about public assets. GovMap brings together authoritative data from VicMap, Crown land information, land titles data, planning information, and first right of refusal information about surplus land. It helps users easily identify and understand what government owns, where it is, which department or agency manages it, and through this information enables government land managers to make more informed decisions about the management of public land and assets. E-comply is the final example I'll be talking about today. So e-comply involves using innovative technology to drive better processes for land management. It's a pilot project that we're running at the moment. It's exploring how to make the housing approvals process faster, easier and cheaper. The pilot project is between Development Victoria, Brimbank City Council, Office of Projects Victoria and the Victorian Building Authority. It uses digital twin technology, spatial intelligence and machine learning to assess digital building design's compliance with the small lot housing code. The approval process usually takes approximately 7 weeks. By using this innovative technology, we're reducing that time by giving an instantaneous response. And so the use of this technology really demonstrates how we can unlock regulatory red tape in this approvals process. So thanks so much for listening to me today, and I'm happy to take any questions in the Q&A. Thank you.